I'm going to be upfront. This is the first time I'm talking about this topic, so I'd love any suggestions anyone has on how to make it better. This is quite a complex topic, and I'm going to try and keep it as light and as simple as I can. I'll keep the amount of code to a minimum. But yeah, it's quite a complex and difficult topic to think about. Like if we're all used to using Claude Code or Codex or any of the CLI-based tools, we're going to start talking about like how do we start building our own. So it gets a little bit hairy in places. But I want to start with a concept that I keep, and if you've seen me speak any time in the last 2 years, I'm going to keep repeating this statement over and over again. But if we want to have good engineering outcomes from using these tools, we actually have to really put a lot of effort in and think about how we engineer the system that we build around it. So that's, our prompt files, like writing good prompts, it's setting up good skills, hooks, sub-agents, creating deterministic backpressure, all those great things. And once you sort of do that for a fair while and you start trying to get your agents to run longer and longer, my experience has been that it'll still drift. And that's how I ended up in the world of harness engineering, because I was like, well, I've got this code structure, how do I keep driving it to keep going? Because what I wanted to do was try and beat my own record of having it run for 3 days without me touching it. And I wanted to see just how far I could go with it. So my challenge out to everyone as well is like, if you're going to get into harness engineering, it's 3 days and about just over 2 hours is my record runtime for having it without me touching it. So I'd like let's create a leaderboard. Let's see who can get the highest ones. Yes, I have a number of different roles and a number of different hats. I'm just going to call out right now, I'm speaking in a personal capacity or as my position as a fellow at the Australian Institute of Transformation and AI. I am not speaking on behalf of Bankwest today, just so we are clear. What I want to talk about is we talk about a lot of things, and I've said agentic engineering probably 3 times already so far. I kind of wanted to bring in what I think agentic engineering is. I'm sure everyone has their own definitions. These are the ones I'm going to work with for today. So really what we want to do is talk about where we're going from on the left, where we're vibe coding, which is, for me is that repetitive 3 o'clock in the morning, you're still typing in there, just one more prompt, just one more prompt, just one more prompt, right? It's that or Civilization 6. For some reason, I end up at 3 o'clock in the morning doing one of those 2 things. And what I want to think is how do we start bringing more structure and more good, solid engineering thinking or systems thinking into how do we actually use these tools to produce good quality code? So for me, agentic engineering is about we're trying to work with formal specifications. We're looking at how do we use memory, how are we writing quantifiable acceptance criteria, how are we creating that really good, solid deterministic backpressure. So we're using tools that produce the same output every time we use them to judge the quality of things before we ask the non-deterministic LLM to provide us any feedback. And we're going to look at where we're doing. So if I find myself I'm poking at the thing, at the agent, I'm just poking around, that is when I'm building I'm exploring, or I'm trying to build a prototype, understand something in a little bit more detail. If I'm trying to ship something that's important, I need to go and actually spend a lot more of my effort on the other side of the fence. And that is setting up the environment, writing really, really high quality, good specifications. Really, I think about it as we've made the programming part really, really fast now. The tools can spit out code faster than I think any human can reasonably. But what that is it's a sausage. We've pushed in here. All we've done is move the contents of the sausage to either side of that. So we have to look at what do we have to do up front before we use the coding agents, and what do we need to do on the back end of that? So there's still the same amount of efforts required. We're just changing where we're distributing that effort now. You're going to see a lot of people, again, this is my version of what I think is an agentic SDLC. This is how I think about that sausage. So up front, I'm a big believer in specification-driven development. Specification-driven development. That's a one today, apparently. So I spent a lot of time co-developing with an LLM. And that is about writing my spec, getting it nice and high detailed, explaining it's either a feature or a whole system. I'd strongly recommend doing it at a feature level. Don't try and one-shot a whole system. It's still very, very hard, although that's also a fun challenge to try. But really it's getting requirements in the old school greybeard style of ears, which is the system shall, the system must, the system should, the system won't, all those sorts of things. Unit test scenarios, integration testing scenarios, and acceptance criteria, ideally quantifiable. We take all that, we spin out a plan, we get it to spit out a plan into slices, and then we go into the agent loop. So I talk about it as 3 things. The inner loop, that is a coding loop, it's spinning fast, right? So it's as fast as the LLM can go, and then you get frustrated with how slow that is, so you start 2, and then you start 36, and then your laptop catches fire, or your credits run out in 8 minutes, and you're like, well, I can't do anything for another 6 hours. Your middle loop, where you're creating that deterministic backpressure. This is where you're putting a lot of tools, a lot of analysis, and feeding back into the inner loop. Any failure of any of your tools in the middle loop goes straight back to the inner loop to be repaired. And it's basically we're fast inner loop, still very fast middle loop. And then we go out to the outer loop, which is where we actually deploy into production and thinking about anti-fragility and feature flags and different deployment models and everything else. So how do we feed information back from our live production system back into the inner loop when we find an issue, right? I've been a startup CTO many, many times in my life. I've started many startups. People tell me it's possible to make money selling software. I have no idea how to do that. I don't actually believe it's true. So if anyone wants to come at lunchtime and tell me what to write in those question marks, I'd be very, very thankful. And apparently that then leads to profit. Again, never seen it myself, but people tell me it's possible. I really want to come from this is what I want to do is I want to have an idea, as harebrained as whatever idea it is, and I want to just be able to write it down, spend a little bit of time writing it down, and then I want to walk away and not think about it until I have a fully working version of my idea out the other side, right? This is the dream that we've been sold as software engineers for since, I don't know, since software engineering was a thing, since 1940, whatever, 1930, whatever. Every tool, every product ever has promised that, you know, it'll be more human, usable, you don't need to be an engineer to use stuff. We all somehow still have jobs today in 2026. But I want to really, this is where I come at harness engineering from this point of like, how can I drive more and more of it, and I have to be less and less involved, right? The reason why I want to do that is because, like I said, is I want to spin up another one and do my second idea, and my third idea, and my fourth idea, because ideas like come quickly and you want to experiment, right? I also want to talk about tokens. Like we've all seen what's happened. Tokens, the top price of tokens isn't dropping as quickly as anyone I think was projecting them we were going to. Turns out people want to make money. You know, if you want to IPO your own business, it turns out you need to show a reasonable return on the investment you are making before you can actually try and sell it on the market. So I think starting to think about how we're using tokens and how to effectively use a resource is actually starting to become a thing. So last year, and even up to probably 2 months ago, token maxing was what all the cool tech bros were doing. I had to check with a couple of the grads how to spell token maxing. I wasn't sure if it was 1x or 2. I'm too old to understand these things. But we want to start thinking about how we're efficiently using our tokens now as well. So I come at it from this idea of, and everything I'm going to talk about is going to boil down to this one simple idea, right? Is I want the model, or LLM itself, is a reasoning engine. I should give it reasoning problems. Where I need judgment, the model should provide that for me. If something is deterministic or formulaic, I already have tools that can do that for me. It's called code, and I have a tool that can generate code. So what I can do is I can combine these two concepts and go, okay, anything that doesn't require reasoning or like a decision to be made should just be straight code, right? Easy to understand, I can unit test it, I can run evals on it and improve it, et cetera, et cetera. Sorry, this slide might be out of order actually. I think like we don't really talk about can the agent write code anymore, right? I think we're quite comfortable the agent can write code now. It's now the quality of the code and how do we drive that quality effectively. And you know, you've heard me say backpressure about 6 times already, and backpressure is one of those really vital things we use to do that. But I think what we need to talk about is like where our failure modes come from, right? So poor context creates poor outcomes, right? Having the wrong context available in a thing will actually steer it to make wrong decisions as well. Asking it to self-review itself, especially if it's a weaker model or we don't have a very strong idea of what quality traits we're looking for, creates a lot of noise and a lot of churn. And really, I suppose I boil it down to this thing of like, what we need is a proper control system around how these things work and not hints and the occasional pep talk. And hints and occasional pep talk are hooks and skills in this story, right? So when we talk about harness engineering, really, the agent is a model and a harness. The harness is literally just everything else around it. So all your tools, skills, permissions, whatever workflow you want to run, observability, you should all be plugging observability tools into your agents if you're not. So really what we're talking about here is how do we build the wrapper around the LLM to create the outcome we want. So I'm a big fan of PyDev. There are other frameworks out there. You can feel free to use whichever one you like. You can even write your own if you want. I'm lazy. I took one that was off the shelf and reasonably well supported. And if you use OpenClaw, PyDev's actually the underlying harness infrastructure under OpenClaw now. So it's got a fair amount of use. It is a very minimal framework for defining a harness. It basically gives you a terminal user interface, some of the standard basics of how to load an AgentMD, skills, and the basic tools of like edit a file, read a file, call bash. That's about it. That's all that comes out of the box, right? You build everything else you want on top of this. So this is one of those times where we take like real basic primitives and we build complex and emergent things by taking a lot of basic stuff and layering them together until we get a lot of complexity, right? Just like the LLM itself, we're doing emergent complexity from simple things up in the harness as well. But what we want to do is like, when we want to start going through these loops, and like I was talking about those 3 loops in the Agentic SDLC earlier, that's a workflow that I want it to follow. And until I started working in harness engineering, what I would do is I would actually burn a lot of tokens in an opus, or for, about 10 minutes, the Fable model, the 10 minutes we're allowed to use it for. I would use a really high-powered, high-reasoning, and I'll put it on extra high thinking, and run the workflow I wanted through there, because that was where I needed the decision-making to be done. And like, it's burning tokens. Token maxing is not a thing as of today, right? So we were thinking about it, we're like, well, how do we not do that? What do we need to do to make it so we can drive the LLM efficiently, but we don't need to use tokens where we don't need reasoning to actually be provided? So Pi, again, is like really, really simple. Kind of has 3 kind of internals to it that you really want to understand. And they're really basic, and they should be familiar to everybody. Nearly everything that happens in Pi is an event. It is broadcast on a bus across every part of the software that's every plugin or node that is running inside Pi, and so you can intercept that and do whatever you want with it, right? This is an example. Everyone should have a version of this in whatever tool they're using, whatever setup they have. It should be a hook, or if you're in Pi, do it as an event. But catch it trying to execute bash, catch it trying to delete anything and say, no, you cannot delete files. I don't know how many times I've had all of the different models delete stuff that they shouldn't have. So I now have a hard hook there that says, no, that's not allowed, you're not allowed to do that, right? Heaps of different events. I'm not going to list, this is just a few of them. There's pages and pages and pages of documentation stuff you can intercept. It also has tools. These are registered straight through basic TypeScript, and you can write whatever you want them to do, right? It's really easy to register one. You can then what gets really interesting is like you can basically write the code yourself, you can call out to do other things, you can do whatever you want. But you've basically now got a really simple TypeScript interface that you can define any tool, and you can decide when it is injected into the context that made available to the model, right? It also has these helpful things because it's such a distributed system and like all the different components trying to do stuff. We do things about modifications are actually done on a queue, so you don't get 2 edits trying to bash at the same file at the same time. Very, very helpful. Like a mutation of a file is a sequential operation. And also if you want any of the built-in tools for Pi, you can just override them by installing your own tool with the same name, and it will make it available. And everything, those 2 things, all get wrapped up into an extension. It's a simple factory function that is like able to intercept an event. So that one's just hooking the session start event and just saying, hey, my extension's been loaded. It's the world's most simplest extension you can write. You can create layers of extensions. You can create extensions that call extensions. You can create extensions that have their own extension points. And you can get into all sorts of crazy, right? You're basically, once you're at this point, you're in TypeScript. You can do whatever you want. With extensions, if you really love Claude Code, you should probably use Claude Code. But if you really want to use Pi, you can also install a whole bunch of plugins that make Claude Code, that make Pi work exactly like Claude Code. There are extensions that provide every feature that Claude Code has. Well, you can install them and make a Pi Claude Code, which is great because what you can have is if you really love Claude Code but you want to use GPT, because Pi is flexible, our model you put behind it, you can recreate the Claude Code user experience and then use GPT in the back end instead, if you wanted to. So yeah, there's a huge marketplace of existing extensions. There is a huge market. So like one of the ones I always use is a workflow one, which then has extension points for me to then be able to register workflows that I wanted to execute, which is really, really powerful. I want to just quickly talk about like prompts, contexts, and harnesses. So really we have 3 layers of how we configure Pi. So prompts are obviously the highest level one. That's the stuff we feed straight to the agent. Great, the classic one, fix this, make no mistakes. That's how you always write good code with these tools, right? Just tell it to not make a mistake. We have all the context, and I'll talk a little bit more about context later. But that's like all of the files and everything else we want to feed in there. And that is like whatever you're used to using. It's all your markdown files, if you've got RAG systems or MCPs, all that sort of stuff, that's where you can wire all that stuff in. But your harness itself is actually about that, how we start bringing in that phased, repeatable, and bounded behavior. Because the prompts, like as we all know, are non-deterministic. You run the same prompt twice, you're not always going to get the same output, right? So for things like decisions, we want to make things that are actually black and white, we want to swap over to code, and that's where we bring in our harness code, because that gives us that repeatable, bounded, and deterministic behaviors. So I'd say what you want to do is, and my advice to people when they're first looking at this is to actually go and play, like fire up Claude Code or Codex, and play with the goals or workflows that are in there. They torch tokens like anything. But while you're exploring and trying to work out a workflow you like and whether you think it's a good idea or not, I still thoroughly recommend you should actually just do it in whatever tool. Take that learning, discover the patterns about the way you're working or the way you want to work, and then you can think about how to convert those into a Pi harness or whatever harness framework you're using, right? And this is again about only, instead of just running that workflow, finding the workflow you like and running it over and over and over again, and thinking about how many tokens you're spending when you're doing that. If you're going to keep doing that and you've got a workflow you really, really like, this is the time we should think about swapping it over to be your own custom harness, because it's code it's running, it's not burning tokens, it's just executing TypeScript code, right? So like I said, I think a lot of it is about thinking about like, how do we break down where the thinking occurs and where do we actually trust the LLM to work and where do we trust the thing? So, we've got the basic primitives and they're the same across both, right? We have a Claude MD or agents MD file. We have skills, sub-agents and hooks. We have them in both. So we're not sacrificing anything that we're used to working on if we swap to using a harness, if you install the extensions that support these things, obviously, because these are like, everything's a plugin by the core framework. But what we want to do is get into this state of like, instead of the LLM looking at the thing and processing its own thinking or whatever output it's generated and everything else, and then making a decision about what step in the workflow to do next, what we want to do is start thinking about getting into a state, artifact, gate, and transition model, right? So think of it as a state chart. We're in this state. I have these artifacts that have been produced. I have a gate, so it's a decision, like what check do I want to make against those artifacts? And then I say, transition to this next state for me. And I can do that all in code, right? Claude or the workflow tools can do it. If you run them long enough, my general experience is like a lot of things that it does. If you've ever asked it to edit something or refactor something, and it, like your tests were passing and you ask it to refactor and the tests are failing, and you've seen the LLM come back and be like, oh, that's completely unrelated to my change. And you're like, well, you're the only thing editing code here, and so like I don't know what you thought happened, but like you did do that. And you know what I mean? So like they're not always like making super well-reasoned checks, or they'll find creative ways to get out of a loophole and skip over something that is stopping it trying to make progress, because it's trained and it's designed to try and make progress through a thing. And what we're really doing most of the time is trying to slow that progress down and be like, no, you need to go back and think about these things, or you need to do these extra things. Stop skipping over them. You need to do them for me. Right, so that's where we look at it. It's like, I want the LLM to do the work inside a phase or inside a state in my state chart. It doesn't own the workflow though. The workflow is owned by me in code. I'm going to keep saying it over and over again. We can also do some really interesting things about how we can manage our context and like managing our token buffers as well. Claude, traditionally, like you install an MCP or you install a bunch of tools and skills. They're available to every agent everywhere with an asterisk, but like generally. I can actually really choose for this specific phase of this workflow, these are the only tools it's allowed to have. So it can't go and decide to do a git hard reset on my repo when I've asked it to review a document, which has literally happened to me before. So you can actually get really specific because you own the tools, you own the state chart, you can make the determination. You go like, all right, when you're going to spin up, only register these tools in this state. So only those tools are there. Only those tools are added to the system prompt. So when it goes through to the underlying model, you can only see the ones that you've decided. That's it. Like I said, like we've all probably experienced as well. I've spoken to people like, say, oh, I can use hooks to do certain things and block it. I was like, we've all experienced hooks not actually firing 100% of the time, right? Because the LLM's making those decisions. It's a non-deterministic system trying to make a decision where we want an actual binary outcome. It works 99.9% of the time, but it does not work 100% of the time, which is still not good enough, right? The other one we want to look at is we want each phase, or ideally, what we want to think about is having each phase create the relevant artifact that generates proof that it did the thing that we asked it to do. So if we're asking it to write a plan, there should be a plan file that comes out the other side. Now, the simple check or the simple gate for the transition in your state machine is, well, does the plan file actually exist? It's probably a good check to start with, right? Probably not the greatest one, but it's a start, right? But if you want to define a schema or a template for what you want a plan to look like, you can now on that transition have an action there, and you can write some code that says, well, if you're going to try and transition out of a planning state into an execution state, well, does the plan file exist? Does it meet my schema? Is the content that I need, is all the content in the template actually filled in, et cetera, et cetera. One of my favorite ones is the actual second one, which is, I assume a lot of people have seen the Karpathy agents, and one of them is like only make surgical changes, don't wander off and make other edits. One of the things you can do is in a planning thing, you can actually ask it to like work out what it thinks the sequence of edits it needs to make are, and you can actually capture that in your artifact. And then when you go to implementation, you can be like, what files did you edit? Did you edit only the files you thought you were going to edit, or did you edit a bunch more? And you can now actually have a reasoning step to be there. Well, like, did you need to do that? Did you decide to go and, I don't know, randomly refactor something else at the same time because it felt like a good idea at the time? So we can start tuning exactly how these transitions occur based purely on artifacts, right? Tests failing, like I said, I've seen it fail unit tests and be like, oh, someone else broke the unit test, I'm just going to keep going. You can stop it. It can't transition through it because it's code that you've written, that you've hopefully also unit tested for the record. Another one where we can play around with how we're saving tokens when we're in a harnessing is we can actually be really, really clever about how we generate or what context we're actually exposing to the LLM. So we can find the smallest amount of context that is sufficient for the problem or the phase that we're in and only give it that context and nothing else. So instead of having it read entire files to try and hunt for something or querying a graph frag system or an MCP to get a bunch of stuff, we can be very explicit about what context we actually allow to go through to the agent to execute. And again, that is a great way of saving the amount of tokens we're churning, right? It's also like one of those things, like if you leave agents running a long time, your context window, like the compaction and everything else, you'll get a little bit of pollution through there. I very strongly recommend if you're going to work like over longer horizons, you use a lot of sub-agents, so you're always getting fresh context. But you will have somewhere a very, very long-running context that is normally your orchestrator. It will get a little polluted over time. It will get a bit of context leakage, and it might start to like go slightly off kilter from where you want it to, because of the compactions have been happening over and over again. So it like misweights context, and it will take actions that you didn't necessarily want, especially on your orchestration loop. That's your thing that's just driving everything. And if you have that happening there, then like God knows what's going to happen. Like it's going to go off track and not work the way you want it to do. So this is another good way of like being really surgical about like what context we're providing, because the actual overall orchestrator is no longer an LLM. It's actually a for loop. Right, it's like while there's more stuff to work on, it's all a Ralph loop, you know. So this is where I think, like, again, I was just talking about workflows, but like, this is like engineering work is very rarely a linear sequence, right? I don't think I've ever seen or worked on any engineering project that's ever been like do A, do C, do C, do D, do E, and you're done and everything's great. Like, there's always iteration, there's always mistakes, there's always, you know, real world backpressure for every engineering project itself. So again, instead of having the orchestrator loop be an LLM, and again, probably a high-powered model with a high reasoning thing, so very expensive on tokens, this is a state chart. Encode the state chart is TypeScript, and then iterate, and then work through the state chart. So every feature or every task it needs to go through goes through that sequence. The LLM does a reasoning inside the box, but it does not do reasoning on the lines. Well, it can do if you want, but I would strongly suggest you put a bunch of like not reasoning steps in there as well. Another one, and this kind of became popular a couple of weeks ago, maybe, I think, well, at least in the circles I move in, people were talking about token compression proxies or tools that were sitting in front of things to like reduce the amount of tokens that were, or the amount of embedding that was having to go across for a tool call. So people were like creating all these crazy ways of doing stuff. Do you know what's great? You can write a tool in TypeScript and you can take, I don't know, the massive output from running PyTest and go, well, actually, the only bit I care about is how many tests passed and failed, and maybe which tests failed. So I can parse the output of PyTest, and the return result from my tool is only the bare minimum that I need for the loop to work. So that's how you can massively cut down your token usage as well. So you don't need to spend lots of tokens with greps, tailing logs, catting files, trying to filter stuff, getting it to generate JQ scripts to pull out little bits and pieces of a JSON file, because you can write that in TypeScript once. Most tools produce machine-readable output, so you can easily create a parser. So your tool is now way more token efficient when it's being used. Yeah, I've already kind of talked about that one. The other one, and I think I am coming to the end, I promise. But I think the other one is like the thinking log and the transcript is really, really like interesting. If it starts going off kilter and you want to understand why, the first thing you're gonna do is like pull up the log, Control-O it to get like it into thinking, and then you're gonna go through every step, which is good. It's helpful, but a way more helpful thing is like you can emit, if you're controlling the harness, every decision that is made by the harness, you can log, and this is what I was saying about make sure you include observability, right? So every decision, so like what the input data fact is, why it failed, why the check did or didn't pass. All the stuff that it goes into making that decision, and however complex the decisions you want to make in your workflow are all loggable. These mean that you can now start tweaking your harness, and you can run evals against them, and you can start debugging and understanding your harness as well. So again, we're taking something from a somewhat black box and we're opening it up and we're making it very, very transparent. I'm just gonna, sorry, I'm running out of time. Deterministic checks always have to run first. Like always run your deterministic checks before you do anything else. Again, as a token saving mechanism. If you can run a tool, especially one in a harness that you've handwritten or you've got code to vibe up, Claude to vibe up for you, you run those things because they're deterministic, and then only ask the LLM to do adversarial review of whatever's happening afterwards. We're trying to, again, save tokens, right? If we can get the failure, if we can get it to fail back and go back into the inner loop quicker without spending tokens, we have more tokens for the loop to actually deliver work, right? Best practices, I'd say what you want to do, and next slide is homework because we're in a lecture hall, so I had to give everyone homework. I came in and actually added an extra slide to this deck, which means I might go slightly over just because I thought I'd give everyone homework. It's been a while since I've given a lecture in a lecture hall. But these are some ideas you can look at about like things you can do. So especially if you're getting into loop engineering, or you're seeing your workflows has a lot of loops, you can start looking at having loop counts and how many times it's allowed to loop around in that transition state before you go, hey, that's like basically an infinite loop, let's jump out. Let's get a human involved. You can look at setting token budgets on stuff if you wanted to as well. You'd be like, hey, you can do this step using an agent, but you're only allowed to use up to this many tokens. And then if you go over that number of tokens, we're going to abort out and find another way to do it because it's costing too much money. Yeah, version test and continually refine and edit your harness components. Always make sure they justify their existence constantly. When they stop paying rent, evict them. Get something else, rethink at what you're doing, try and find a different angle to it. Don't get married to the code you've got in your harness. Like, it's like throw it away, get another one. Someone writes a version of a plugin, that's awesome. You don't have to maintain your own thing, grab their thing, right? Like good engineering practices again. And use evals to constantly improve them. So this is, again, where you have all the logs and you have everything else. You can actually go back and mine all this stuff because you have it in structured, well-structured machine-readable output. And you can then go, all right, I'm going to change this like this. What would happen if I did that? Like, would the check still pass? Because all the artifacts that were there from the run are kept. So you can actually almost go back in time and go, well, why did we make the decisions we made? Why did the loop do what it did, et cetera, et cetera. Last slide. I'm going to be bang on time. So I would say homework for everybody. If you're interested in harness engineering, go and look at a proposition you're using over and over again. Or a workflow you find yourself. I know a long time before I started doing this, I would have my Obsidian Vault, and I would have a bunch of templated prompts there, and I'd be like, okay, I'm going to do this thing. I'd go cut and paste that prompt in to Claude code. If you're doing that, probably maybe it's a good idea to start looking at writing a simple harness for that, because now you don't need to keep cutting and pasting things. You've got a harness that drives it for you. Yeah, go to the small thing. I'd say that the basic harness to me is like have a read-only plan phase. Have a bounded context, time, iteration, whatever criteria matters to you, a bounded implementation phase, and some deterministic verification. Create artifacts, measure its performance. I don't know what else happens after that. There's more question marks that you're filling in. Wish you discovered harness engineering a lot earlier and cry in your life, where you could have been using them for productive work instead of just having the thing, trying to steer it. Right, that is the end of my talk. I'm holding everyone up for lunch. I'm conscious. Are you looking for questions if you want? Otherwise, I'll ask questions out there at lunch.